Welcome to the 8th part of VCAA Math Method 2022 exam paper series. In this video, we will present exam paper 2, section A, questions 17 to 20. To solve question 17, it requires students have good understanding about the concept of average rate of change as well as the instantaneous rate of change. Question 18 is a binomial random variable distribution related question. Students are required to know how to work out the expected value, standard deviation, as well as the conditional probability according to the context of the question. Question 19 is a problem-solving question, requires students to apply quadratic technique to solve it. Question 20 is a normal distribution related question in which certain knowledge of circular functions is needed. Welcome to this VCAA Math Method exam paper series. This is section A of 2022 exam 2 paper. There are total 20 multiple choice questions in section A and 5 extended response questions in section B. In this video, we will present questions from 17 to 20 in section A. In question 17, a function g of x is continuous over the domain within a closed interval from a to b, has the properties as stated. The average rate of change of g of x between x equals a and x equals b is positive. The instantaneous rate of change of g of x at the point x equals a plus b all over 2 is negative. The question here is to determine whether the function on the closed interval from a to b is a many-to-one, one-to-many, one-to-one, strictly decreasing or strictly increasing function. According to the given properties of the function g of x over the closed interval from a to b and based on the extreme value theorem, there is at least one local maximum within the interval from a to a plus b all over 2. In the meantime, there is at least one local minimum in the interval from a plus b all over 2 to b. Hence, the function is the many-to-one function. So the answer for question 17 is A. In question 18, a binomial distribution random variable with n equals 20, p equals 0.88. The question is to find the value of A if the probability of x is greater than or equal to 16, given that x is greater than or equal to A is 0.9175. Since the binomial distribution has parameters n equals 20 and p equals 0.88, the mean of the distribution equals n times p, which equals 17.6. Its standard deviation equals square root of np times 1 minus p, or in parentheses, which equals 1.453 approximately. According to the given criteria, the probability of x is greater than or equal to 16, given that x is greater than or equal to a, equals the probability of x is greater than or equal to 16 over the probability of x is greater than or equal to a, which equals 0.9175. The probability of x is greater than or equal to a equals the probability of x is greater than or equal to 16 over 0.9175, which equals 0.9998, which gives a equals 12. Hence, the answer for question 18 is B. In question 19, a box is formed from a rectangular sheet of cardboard which has a width of A units and a length of B units by first cutting out squares of side lengths X units from each corner and then folding upwards to form a container with an open top. The question is to find the value of X in terms of A, B, and C, so that the maximum volume of box occurs. According to the given criteria, the volume of the box can be expressed as a minus 2x, or in parentheses, times b minus 2x, or in parentheses, times x, which is expanded and simplified to 4x cubed minus 2 times a plus b, or in parentheses, times x squared, plus abx. Then we find its derivative with respect to x. dv by dx equals 12x squared minus 4 times a plus b, or in parentheses, times x plus ab. After being equated to 0, x can be found using the quadratic formula. Therefore, x equals a plus b plus or minus square root of the sum of a squared plus ab plus b squared, then all over 6. Since x is less than a over 2, which is less than b over 2, x equals a plus b minus square root of the sum of a squared plus ab plus b squared, then all over 6. Hence, the answer for question 19 is D. In question 20, a soccer player kicks the ball with an angle of elevation of theta degrees, where theta is a normally distributed random variable with a mean of 42 degrees and a standard deviation of 8 degrees. The horizontal distance that the ball travels before landing is given by the function d equals 50 times sine of 2 theta. The question here is to find the probability that the ball travels more than 40 meters horizontally before landing. Since d equals 50 times sine of 2 theta, which is greater than or equal to 40, sine of 2 theta is greater than or equal to 40 over 50, which equals 0.8. According to the properties of the sine function, 2 theta is greater than or equal to 53.13101 degrees, but less than or equal to 126.8699 degrees, which gives theta is greater than or equal to 26.5651 degrees, but less than or equal to 63.4349 degrees. Therefore, the probability of theta is greater than or equal to 26.5651 degrees, but less than or equal to 63.4349 degrees, equals the probability of theta is less than or equal to 63.4349 degrees minus the probability of theta is less than or equal to 26.5651 degrees, which equals 0.9695. Hence, the answer for question 20 is A.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.